this video, we're talking about simplifying complex fractions. And when we say complex fractions, we mean fractions that have variables or letters in either the numerator and or the denominator, or fractions where we have a fraction for the numerator and or a fraction for the denominator. Before we get to examples with letters or variables involved, I want to refresh on just a real number example. So in this first example here, we have 1/2 divided by 1/4. So we have a fraction divided by a fraction. So there's really three fractions here, the entire fraction, and then within the numerator, another fraction, and within the denominator, another fraction. And we're trying to find out what happens when we divide 1/2 by 1/4. Well, I have a circle here, and this is just going to be our pie chart. If I take 1/2 of this circle, so if I say that this here is 1/2 of the circle, so I have 1/2 for my numerator, what happens when I divide this by 1/4? What's my result going to be? Well, if I draw fourths inside my 1/2 here, so this is going to be about a fourth here, and this is going to be about a fourth here, and what I see is that I can fit 2/4 into a half. So the result of this should be 2. But how do I do that if I can't figure it out with my pie chart if I just have letters like this? Well, mathematically, what we want to do is take the fraction that's in the numerator, or whatever value is in the numerator, so in this case 1/2, so we're going to say 1/2, and then instead of dividing by 1/4, we want to multiply by the reciprocal. So in other words, instead of dividing, we want to multiply, so we do the inverse operation, and then we take the reciprocal, meaning we flip this upside down. So instead of 1/4, we'll do 4/1. So we change the division to multiplication, and we flip this fraction in the bottom upside down, and then we just do our multiplication. So if we multiply our numerators, we get 1 times 4 is 4. If we multiply our denominators, we get 2 times 1, which is 2. 4 divided by 2 is equal to 2. And that makes sense to us because when we did our pie chart here, we saw that there were 2/4 that went into every 1/2. So we can do it this way, or we can do it algebraically. We can do the math, and we get an answer of 2. So now if we apply that to problems with variables, here we have a over b divided by c. So we have our larger fraction here. Inside this larger fraction, we have a fraction in the numerator, and then we just have a single value in the denominator. One thing to note before we go ahead and do the math is that we have to indicate that the denominators cannot be equal to 0. And we have to look at all three denominators. So one thing we want to note first is that in the denominator here we have c. But remember, this is the same thing as c over 1. So now we have a fraction a over b divided by another fraction c over 1. So looking at our denominators, we'll start with the denominator within our numerator here, which is b. We have to say b cannot equal 0, because remember, the denominator of a fraction can never be 0 because we can't divide by 0. So b cannot equal 0. This denominator is 1, so we could say 1 cannot equal 0, but of course we know that that's always going to be true. 1 is never going to be 0, so we don't need to write that one. But we also need to say that the larger denominator here of this larger whole fraction cannot be 0. So c over 1, or just c, cannot be equal to 0. Now, once we've qualified those two things, once we've indicated that our denominators cannot be equal to 0, we can apply the same math that we did to this problem up here. So we're going to take our fraction in the numerator, a over b, so we're going to take a over b, and then instead of doing our division here, we're going to multiply instead, and then flip our c over 1 upside down. So we're going to make it 1 over c. When we multiply across our numerators, we get a times 1, which is a, and when we multiply across the denominators, we get b times c, which is bc. We can't simplify this any further, so a over bc is our final answer. Now if we look at a third example, here we have a over x divided by b over a plus x. So we have our larger fraction, the whole thing here. Then we have a fraction in the numerator, a over x, and then a fraction in the denominator, b over a plus x. So if we want to write our conditions like we did here, what cannot be equal to 0, we'll take the denominator from the numerator, which is x, so we have to say x cannot equal 0. We'll take the denominator from the denominator, a plus x, and say a plus x cannot be equal to 0. But we also have to say that the denominator of the larger fraction cannot be equal to 0, so we're going to say b over a plus x cannot be equal to 0. So all three denominators we have to indicate that way. But then we can just do our math. So we'll take the numerator fraction a over x. Then instead of dividing, we'll multiply. And then we're going to flip this fraction upside down. So instead of b over a plus x, we'll do a plus x over b. Now this is where it gets a little bit tricky. Because we're multiplying here, we need to remember that we have to apply the distributive property and distribute this a across this a plus x. One thing you can do just to be safe is put parentheses around at least one of the fractions to help remind you. Now this looks like a distributive property problem where we want to distribute this a across the a plus x binomial term here. So our result then is going to be a times a, which we know is a squared. We leave the plus sign here. And then a times x we know is ax. We just distributed that a across the a plus x when we multiplied out the numerator. Now when we multiply out the denominator, we get x times b. We want to list our terms in alphabetical order, so we do bx. And this is the result of a divided by x divided by b divided by a plus x.